we're back. Today is Friday.
Happy Friday!
Happy Friday! Like it's any different from any other day.
Really?
Well,
It's Friday.
okay.
It's been Friday for all of my life.
That's... yeah. Okay, so we're going to go over the lab first. And the lab was called Changing Steel Wool. Changing Steel Wool. And you have all your write-up done now because you got to see what happened. And this is what happened overnight. It was all blown up. Well, first of all, the balloon was out here. Remember that? And we soaked the steel wool in vinegar. And then we put the balloon on. And then that day, as I was sitting here doing my work, the balloon got sucked in and the balloon blew up.
Oh.
And the bottle collapsed. The bottle got dented in. Well, now it's all, the balloon is all not blown up anymore. The bottle isn't collapsed anymore. It's back to being round. The steel wool is still a pretty kind of rusty brown color. But it is supposed to be sealed. So let's see if the mass changed. I didn't change the setting on the balance. So let's see what happened. It wouldn't surprise me if this got lighter, because I don't know about the seal up here, if it kept everything in, but I don't know. It looks like it stayed the same. Let's see. Oh my gosh. It stayed the same.
Stayed the same.
It stayed the same, even though the beginning and the middle and the end all look really, really different from each other. The only thing that stayed the same was the balloon is still yellow. That's about it. Everything else changed. The shape of the balloon, the shape of the bottle, the color of the steel wool, everything else changed, but the balloon's still yellow because the mass stayed the same. So we had questions on your conclusion. We have 3 conclusion questions. Question number 1, what caused this reaction? Well, when metal gets wet, that would be the steel wool and the vinegar, and it mixes with oxygen, what happens to it? Metal?
Rusts.
Rust. It rusts, okay?
Kind of like my name, Rust.
Yeah, close. So that's what happened. That's why the steel wool got that kind of icky, orangey, gross color. Okay, so question number 1 is the reaction was rust. It was the oxidation of the metal. Number 2, write the chemical equation of iron rusting. Okay, so we've got iron rusting. I have it right here somewhere. Okay, iron rusting. Okay, iron is Fe and oxygen is O2, and this goes to iron oxide, Fe2O3. This is the chemical formula for rust. So we have Fe, iron, plus oxygen yields rust. So that is the chemical equation. However, it's not balanced. This is not balanced. So we have to balance it. So for iron, we have 1 here, and oxygen, we have 2. For iron over here, we have 2, and for oxygen, we have 3. Okay, so this is a problem because those aren't balanced. So let's get 2, if we put a 2 here, can we do that? Does that work? I think that works. Okay, so if we put a 2 here, let's put a 2 up here. Now we have 4 irons and 6 oxygens, and to balance that, we need 4 irons over here, and we need 6, so we can do a 3 there, and now we have 6. So now this is our balanced equation for the chemical equation of iron rusting. That's it. And there's water in there too to help the process go. Okay, now, is this a synthesis? This is number 3. Is this a synthesis or decomposition reaction, and how do you know? Okay, synthesis, I'm just going to talk about what each of those is, and then I'm going to look to see which one fits. Synthesis is when you take simpler atoms, combine them to make something more complex. Decomposition.
Me. Decomposed.
Yes, decomposed. Decomposition is when you take a more complex molecule and break it down into simpler substances. So we have iron, that's one thing all by itself. Oxygen, that's one. So these are pretty simple substances here. And then it makes a more complex substance. So this is a synthesis reaction. We have 2 simple things, we get 1 more complicated thing. So that is a synthesis reaction, and that's how we know, because we start out simple and get more complicated. And that's that. So let's go to our focus question. Focus question, actually you could just have a 1-word answer. What happens to masses of reactants and products? What happens? Nothing. Nothing. Nothing happens to them. They don't change. They stay the same. So I'm going to write the masses, because I know how much you guys love to restate the question. The masses of reactants products stays the same. This is in your science notebook, by the way. You wrote this a while ago, last week probably. And this is because they stay the same because of, not because of the law of conservation of mass, but the law of conservation of mass is what explains why this happens, okay? So the masses of reactants and products stays the same. The law of conservation of mass explains this, okay? Lavoisier was the guy. Antoine Lavoisier was the guy. Yeah, he was French. He's French. Probably had a poodle. Okay, so Antoine Lavoisier was the first one to get credit for explaining how this happened. Okay, so that is our lab write-up and our focus question that's in your science notebook. And now you have a quiz to take. Where did I put it? It was right here, Ross. Here it is.
There it is.
Here it is. I got it. Okay. So you have a quiz to take. It's the 9-2 quiz. If you got a packet, then you got this in the packet. Otherwise, it's online on my website under worksheets. So you can either do it online and then just send me your answers, or you can take a picture of it, send it to me, email it to me, whatever you want to do. A lot of people have figured out that all you really have to do is take 20 pictures of your science notebook, send me the pictures, and I enter everything in the grade book. So Illuminate is turned off, but you guys know that I have my grade book. So I'm keeping track of everything that you guys are doing, so you will get credit, so don't worry about that. And take your quiz. On the quiz, it says describe the law of conservation of mass. Number 2 says balance the equation, show your steps. So just like this, show your steps, show how you worked out the numbers. And this Al right here, this is aluminum. It's not Ai, it's aluminum, Al. This is also aluminum, A-L, capital A, lowercase l. And then the last part says rewrite the balanced equation. So figure out what the balanced equation is here, and then rewrite it, the balanced equation. So you would write something like this. And then it says circle all the subscripts and underline all the coefficients. So if you have any subscripts in your answer, circle them. And if you have any coefficients in your answer, underline them.
Yes.
That's it. That's all we have for today. And next week's schedule will be posted later today probably. And if not, then look at it on Monday. And we're going to finish chapter 9 next week. So you have a test on Friday on chapter 9. So we'll finish up with the chapter 9 packet and do, I think we have a lab next week. We have another lab. Of course. We might, I'm not sure, I can't remember if we have another lab next week or not. I think we do. Let me look. Let me look. Let me look.
Does it have aluminum in it?
Yes, we have the exothermic and endothermic lab to do. This is another good one.
Oh, yeah.
Yeah, this is a good one. This is a good one, yeah. Okay, so yes, another lab next week. And all the notes and reading, and then we're taking a test. Okay. That's it. Good to go. Ready?
I think I know why I like aluminum. It's like Illuminati.
I love you. Bye.
Happy Friday.